things on the recording. All right, here we go. Welcome to week 16. We are talking about logarithms and exponentials. Logarithms are the opposite of exponential. Notice see this exponent, once you switch it from exponential mode to log mode, you have isolated the exponent. Okay, that's what you do if you are solving for the exponent and you need to isolate it. Okay, so solving an exponential. Okay, solving an exponential. I notice, the first thing I'm going to do is I'm going to check my table of powers. Okay. And I notice that 243 is 3 to the what power? Fifth? Yeah, 3 to the 5th. All right. Way to jump in right as you enter. Okay, but it's on the bottom. So I'm going to say 3 to the 3x plus 3 is equal to, because I changed it from the bottom to the top, the exponent is not 5. The exponent is -5, right? Because it was a fraction. So cross the line, change the sign. Okay. And now I know that if the bases are the same, if the base is the same, then the exponent is the same. Those should really be plural. If the bases are the same, then the exponents are the same. Okay, so now that I have the bases are the same, I can bring down my equation. So what does the equation look like? Is equal to -5. Okay. And then we subtract 3 from both sides. 3x is equal to -8. Divide by 3. X is equal to, and we're just going to leave it as, we're just going to leave it as a reduced improper fraction, right? That has been reduced, a reduced improper fraction. Okay, so that's how you do those. These 36 and 216, you're going to look at your chart. They are powers of 6. This is on your own. I believe in last year's video, I did all of them. Okay, so this is on your own. You can either watch last year's video or stick around and request it at the end. Next. Okay, here is what we're using. So log base answer, and we have isolated the what? What goes on the other side? Exponent. Okay, so Zoomers, be ready to type in the base is what? Correct. Yeah, Zoomers, what's the base? The base is, oh no, but thanks for trying. This little guy right there. Okay, so the base is 19. What is the exponent? Yeah, Zoomers, what's the exponent? Give it a guess. All right. The exponent is over here, -2, 1/361. And you can kind of see that that's logically equivalent, right? Because I'm guessing 19 squared is 361 because it's negative. Cross the line, change the sign. So that's all we're doing. Rewrite in exponential form. Okay. Now we're asking the question, what makes a 3 into a 9? What exponent makes a 3 into a 9? So we are going to convert it to exponential form, but as you get better and better, and as you take higher math classes, you're going to start thinking, what makes a 3 into a 9? Okay. I don't know. So I'm going to put an X over here. What is the base? Yeah, that little number. What is the exponent? X is the exponent, right? Because the whole point of a logarithm is to isolate the exponent. The exponent is the isolated thing. So 9, what do I call 9? 9 is the, yeah. Yeah, Zoomers? 9 is the answer. Okay, so rewrite this in exponential form, please. So I have 3 with an exponent x and an answer of 9. So you can see I'm asking what exponent makes a 3 into a 9. So I'm going to rewrite 9 as 3 to what power? Correct. Yeah, Zoomers? What exponent on a 3? All right, 2. 3 to the second power is 9. And then I say, if the bases are the same, then the exponents are the same, x equals 2. So what exponent makes a 3 into a 9? 2. So log 3 of 9 is 2. But here's, or you could just say 2. Okay, there's another way to do this that's called change of base formula. X equals log base 10 of the answer divided by log base 10 of the base. Now, why am I using base 10? Because the calculator will do base 10. You're going to love this method. It looks really clunky right now, but you're going to like it. Now, oh, did you? Uh-huh. I would think more physics, but yeah.
I'm pretty sure it was chemistry. They're gonna do more.
Exponential. Okay, growth, like something was growing. Yeah. Okay. Bye-bye. Okay. Now, so we do log of the answer. Which one of these numbers is the answer? The 9, right? Log of the answer divided by log of the base. Which number is the base? 3. Notice the 10 disappeared. Okay, so if this is log of 9, it's an invisible 10. Okay, we just assume, kind of like 3 to the first power. Do you have to put the 1? No, we assume it's a 1. So we are assuming the base is a 10. Okay, calculator. So this is how you're going to type it into the calculator. Log base 9 divided by parentheses log base 10 of 9. Okay. Oh, wait. Depends on your calculator. So log 9. Okay. Sorry. Log, a parenthesis opens, close the parentheses, divided by log 3, close the parentheses. Okay, so it looks like this. And you'll get a 2. So it looks really clunky, but you're actually going to like this method. That one was bad. Log of the answer divided by log of the base. Okay, let's do another one. Okay, first we're going to change to exponential. So we're going to go base, exponent, answer. What is the base for number 5? Yeah, Zoomers, can you type it in, please? What is the base? Awesome. 4. What is the exponent? X and answer. 16. What do we? Ooh, okay. We see a negative involved. Yeah. I'm going to rewrite 16 as, are you done? Okay, did you hit submit? Okay, so you can close that, put that away, and give me your notes and your exam. Okay, so 16, does everyone agree that 16 is 4 squared? Oh, there's a negative coming. Okay, I'm going to do this more slowly. Does everyone agree that 16 is 4 squared? Yeah, are you with me? Because this step is super important. Okay, cross the line, change the sign, equals 4 to the negative 2. So 4 to the x equals 4 to the negative 2. Yeah, does everyone see where the negative appeared from? Cross the line, change the sign. If it was on the bottom and I want to cross it to the top, the negative appears. Okay, if the bases are the same, thank you, then the exponents are the same. X equals negative 2. Yeah? Okay, Zoomers, on a scale of 1 to 10, I need a confidential vote. How good do you feel about that problem? Yeah. Yeah, Zoomers? Can I have a vote? You're there, aren't you, Zoomers? Okay. Fair. Okay, number 6. Let's put an X. Now, okay, good. We're not going to practice the change of base method because we're going to practice that with a later problem. We don't tend to use change of base if the answer is a power of the base. Okay, step 1, rewrite this. Base, exponent, answer. Okay, so what is this rewritten in exponential form? What is the base? 3. What is the exponent? X. What is the answer? 81. Awesome. Okay, now 81, I check my chart of powers. And 81 is 3 to the 4th. Does everyone see that? Yeah, 3 to the 4th. So that is 3 to the 4th. Now we could rewrite it, or we could just ignore this. Okay, if the bases are the same, then the exponents are the same. So I write my equation. What equation comes down? Was it at the very end of the year? It may have been the end to get ready, because it's not, Oh, sine, trig, use trig, sine, cosine, tangent. Yes. Yes, we will get to sine, cosine, tangent. Okay, Zoomers, how much does X equal? 4. Yeah? Are we getting better? Next. What is the base? Oh, wait, let's put an X over here. Base is what, Zoomers? 5. What is the exponent? X equals 1 over 125. Awesome. Okay, chart of powers. 125 is 5 cubed. Yeah. Okay, which is 1 over 5 cubed. What is my next step? Yeah, cross the line, change the sign. Goes up. 5 to the x equals 5 to the negative 3. Okay. What's that stand for? If the bases are the same, then the exponents are the same. Yeah, so our equation is x equals negative 3. Change a base. Yeah, with your calculator, but change a base is really awkward if it's a fraction. You might as well just do it exponential. Okay, so how about this one? Log base 3 of 19683. Guess what? That one's not on the chart of factors. So we could either go 3 squared, no, 3 cubed, no, 3 to the fourth, no. Let's do change of base with this one. Log of the answer divided by log of the base. Let's try it with your calculators. Log of the answer, close your parentheses, divided by log of the base, close your parentheses, equals 9. Which means 3 to the 9th power is probably this. 3 to the 9th power, yeah. So log is used to find the value of an exponent when the exponent is unknown. Okay? Okay. Okay, this one's on your own. Or watch the video. I did it last year. Well, this one's kind of weird. Okay, this one's weird. Let's put an X over here. What's the base? 2. What's the exponent? Zoomers, what's the exponent? Yeah, X, right? The answer is 1. Okay, so I need an exponent that'll make something into 1. I'm stuck. I don't know. Let's go ahead and do change of base. Log of the answer divided by log of the base. Yeah, let's do it. See what we get. Log of the answer, close the parentheses, divided by log of the base. Oh, x equals 0. Yeah. So see how knowing multiple methods, what if you get stuck using one method and you do the other method? But when you're doing the test, show your work. So I know which method you're using. So does that make sense? 2 to the 0th power equals 1? Of course it makes sense because anything to the 0th power is 1. Yeah. Okay. Guys, I love logs. That's like, they're cool. Yeah, they're not bad. Okay. So these are on your own or watch last year's video. Okay. Or request it at the end. Okay. Number 12. 66 is not a power of 3. Yeah, 66 is not a power of 3. We can't change it into exponential form. There is no exponent that'll make 3 into 66. So we're going to have to use change of base, which is log base 10 of the answer divided by log base 10 of the base. So log 66 divided by log 3, the calculator is going to put parentheses in there. Make sure to close them. Okay, everyone give it a try. Log of the answer divided by log of the base is 3. Approximate to the nearest thousandth. Oh, goodness gracious. 8, 1, 3, 5, 8. Tenths, hundredths, thousandths. So that 8 is going to bump this up. 3.8136. Okay, log of the answer divided by log of the base. Tenths. Oh my goodness, look at that, I was wrong. Tenths, this is hundredths. This is thousandths. Sorry. So the 5 is going to bump this one up. 3.814 is your answer. Tenths, hundredths, thousandths. Okay, what? What the heck? Okay. Now, this is called the natural log. Which is log base E. Okay. So we're going to convert it to log base E of 66. So that's what it is. Okay, but look at your calculator. We don't have to do anything. Can you see that your calculator has natural log? Yeah, it's right there. So you're going to hit, now that's what a natural log is. It's log base E. And you're probably asking, wait, what is E? We're going to talk about E later. You're just going to hit natural log 66. Yeah. So if you hit natural log of 66, close your parentheses, you get 4.1896. So ln, it's in French, logarithmic and natural. Yeah, that's why it's called ln, natural log. It is a button on your calculator. All right. Number 14, write in logarithmic form. Log, what's the teeny little number right there? What goes there? Ooh, not the exponent. The exponent has been isolated. Yeah, the exponent's isolated. So this is the base, and this is the answer. Okay, the base goes right there. The exponent is isolated. Okay, that's why we keep practicing. Because it makes sense. But then when you see it 3 minutes later, you're like, I'm not sure. Okay, how about this one? Oh, and here it is. Notice base goes right there. It's a subscript. It is little. It is an itty bitty little number. Log, what's the itty bitty little number? Yeah, Zoomers. All right, 3. What comes next? 243. Notice full size. The 3 is a subscript, itty bitty. The 243 is full size. And what gets isolated? The 5. Okay. We are like ahead of schedule. Have I been going really fast?
It's pretty good. I think we just have a little bit of.
Okay. Wow, we could start next week's. Because next week we start with arithmetic sequence. You know what? We might do one example. Okay, solve the equation. Oh, okay, good. Okay, good. I'm not going too fast. We can also do requests, those ones I skipped. Okay. Now, even though you do not know how to solve exponential equations, you can tell me the first step. Yeah, Zoomers? Even though you don't know what to do with the exponential, obviously, yeah, the first step is, thank you, subtract 2. So 2 to the x is equal to 29. Okay, eek. My exponent is my variable. So I'm going to go from exponential form to log form. So log, what's the itty bitty number? Yeah, Zoomers? Itty bitty. All right. 2, what comes next? 29. And what has been isolated? Ah, that's the whole point. The whole point is to isolate your variable. 2 to what exponent gives me 29? I don't know. So if 29 is not a power of 2, can anyone tell me what my next step is? Ding, ding, ding. Yeah. Change a base. Okay. X equals log of the answer divided by log of the base. Log of the answer divided by log of the base. Okay. Now, when you use change of base formula, you can use any log you want. I don't see any itty bitty little number. I used log base 10. And we can talk about what that means, but because I like 10. If like all of a sudden, okay, if you're watching videos about this, or if you have a friend who's doing advanced algebra in their homeschool, there are some teachers that would rather go natural log of the answer divided by natural log of the base. It doesn't matter. I'm going to hit the log button. They're going to hit the ln button. Now, why? I don't know. I'd rather do log than natural log, but you will see teachers do that. Okay, with your calculators, log of the answer, close your parentheses, divided by log of the base, close your parentheses, and you get 4 point, round to the nearest 10 thousandths, 4.857. $85798. Yeah, 85798 tenths, hundredths, thousandths, 10 thousandths. 10 thousandths. So, bumped it up. 0, carry 1, 8, 5, 8, 4. Notice with me, you could put this. But in science, does that 0 matter in science? Yeah, it's this funny little thing called sig figs. Oh yeah. Oh yeah, that 0 matters. Yeah, you can't just make it go away. But with me, because I'm a nice teacher, I don't care if you put the 0 or not. But with your science teacher, the 0 matters. Okay, 17. Oh, look, I like this. Look, the exponent used to be locked up, and now when we go to log form, it is free. I found that somewhere and I was like, cute. Okay. Next, solve. Okay, what is my first step? Not add 8. Adding 8 is not the first step. Ding, ding, ding. Divide by -8. The opposite of multiplying by -8, awesome, is divide by -8. Okay, now these are going to change. I am not getting a decimal. Well, actually, if I can write the entire decimal, okay, here's the deal. This is 5.625. If that decimal went on and on and on, I wouldn't put it because I'm getting error. I would just leave it 45/8. Okay. But 5.625, yeah, is todo. That is, it stops there. So I'm going to put it. Okay. The next is, oh no, I'm locked up. We need to free the exponent. We free the exponent. Okay. It's locked up in the tower. We free the exponent by going from exponential form to what form? Logarithmic form. Log base answer free the exponent. Okay. Now, my calculator does not do log base 14. My calculator does log base 10. So next I have to do change a base. Log of the answer divided by log of the base. Or you could have that fraction right there. Okay, so we're going to have log of the answer, closure parentheses, divided by log of the base, closure parentheses. The answer is 6, 4, no, 6, 5, 4, 5. Oh, sorry. 6, 5, 4, 4, 8. Round, I was peeking at my notes. Round to the 10,000ths, tenths, hundredths, thousandths, 10,000ths. Rounds to 0.65450. Okay, if you need to go, we are done. We are gonna do a table problem. So write this on your paper, please. I did not give this to you. This is an exponential equation. Okay, you're welcome. Thanks for coming. Bye-bye. Can anyone tell me what number 3 is gonna be? Okay, plug in some numbers, play around with it. Punch, punch, punch. Anyone have a guess? $384. Ding, ding, ding. What's the pattern? Multiply by 4, right? Okay, so let's look at 384. Is it true that 384 is 6 times 4 times 4? Wait, let's start there. Is it true that 24 is 6 times 4? Okay. Is it true that I took 6 times 4 and multiplied by 4 again? Yeah? Is it true that I took 6 times 4 times 4 and multiplied by 4 again? So this is 6 times 4 to the first, 6 times 4 squared, 6 times 4 cubed. Okay, what's this number? 6 times 4 to the fourth, 6 times 4 exponent 4. 1, 5, 3, 6. Yeah, 6 times 4 to the fifth. 6, 1, 4, 4. So this is 6 times 4 to the 0th, right? Anything to the 0th power is 1. 1 times 6 is 6. Therefore, I have figured out the equation. What's the equation? Six. A is 6. B is 4 to the x. Yeah. See how the 6 was always there? The 4 was always here. Can you see that this is the variable? It's the number that keeps changing. The 6 doesn't change, the 4 doesn't change. Okay, now we're going to take requests in a minute. I want to talk about one thing. So add this to the bottom because the notation is difficult. The math is easy. This is sigma notation. That means substitute and sum. It's also called summation notation. Okay, step 1, plug in 1. So we do all of the counting numbers from the beginning to the end. So the next one we plug in is 2. So the next one we plug in is 3. Now, where did those little exponents come from? It was on the end, right? Whatever's on the end has to be on all of them. Step 1, substitute. So we have 1 squared is 1, 2 squared is 4, 3 squared is 9. Step 2 is find the sum. The answer is 14. So you plug in beginning here, ending here, all of the counting numbers, substitute, plug them in, take all those little mini answers, add them up for a total answer. I think you've seen that in the notes, but we have not done it in a review session. Yeah?
I think you removed it.
Okay, maybe I went over it one time. This one?
Yeah. that one was-
Okay. Okay, we are almost done with the semester. Yeah. Any requests? You guys are good doing these on your own? Either, if you can't do them, watch last year's video, fast forward. Yeah? Any questions? Are we good? Okay, Zoomers, thank you for joining me. You're welcome. Bye-bye.